Imagine a universe that goes on forever, no boundaries, no ends. That's the concept of an infinite universe. It's an idea that has sparked the imaginations of philosophers, scientists, and dreamers throughout history. From the ancient Greeks, who first proposed the notion of a boundless cosmos, to the cutting-edge theories of quantum physics and cosmology today, the idea of infinity has been a constant thread. It's a concept that challenges our understanding of space, time, and existence itself. It's a universe where anything is possible, where there are no limits to the variety of structures, galaxies, stars, and planets that could exist. It's a universe where every moment, every particle, every star and galaxy that we can observe is just a tiny fraction of the whole. So the idea of an infinite universe isn't new, but what does it mean in the context of our current understanding of the cosmos? Our current understanding of the universe is limited to what we can see, the so-called observable universe. From our vantage point here on Earth, we can peer out into space and time, observing galaxies billions of light years away. But there's a limit to how far we can see. Why is that, you might ask? Well, it's all about the speed of light. Light, you see, travels at a fixed speed of approximately 186,000 miles per second. This means when we look at a distant star or galaxy, we're not seeing it as it is right now, but as it was when the light we're observing left it. Now, the universe is about 13.8 billion years old. So the furthest we can see is 13.8 billion light years away. This region, from our point of view, forms a sphere around us. We call this sphere the observable universe. It's like a cosmic horizon beyond which we cannot see. But here's the catch. Just because we can't see beyond this horizon doesn't mean there's nothing there. In fact, most cosmologists believe the universe extends far beyond what we can observe. Our observable universe is just a tiny bubble in a possibly infinite cosmic ocean. Imagine standing on a beach looking out at the sea. You can only see as far as the horizon, but you know the ocean extends far beyond that. The same goes for our universe. The size of our observable universe is mind-bogglingly vast. It spans a diameter of about 93 billion light years. That's a lot of space, filled with approximately 2 trillion galaxies, each teeming with billions of stars. But what if the universe extends beyond what we can currently observe? What if it's infinite? These are the questions that tantalize scientists and stargazers alike, driving our quest to understand the cosmos. And they're the questions we'll explore further as we delve deeper into the infinite universe hypothesis. Scientists have hypothesized that the universe might be infinite. But what does this mean, and why have researchers entertained this idea? The hypothesis of an infinite universe is a natural extension of our understanding of space. We live in 3 dimensions of space and 1 of time, but there is no intrinsic reason why space should have an edge or a boundary. If you were to travel in a straight line through the cosmos, you should theoretically be able to keep going forever without bumping into a cosmic wall or falling off the edge of the universe. This concept is not new. Ancient Greek philosophers debated the idea of an infinite cosmos, and it has persisted throughout the history of science. However, the modern scientific understanding of infinity is based on mathematical models and cosmological observations rather than philosophical speculation. The evidence supporting the hypothesis of an infinite universe comes from multiple sources. One of the most compelling is the observation of the cosmic microwave background, the afterglow of the Big Bang. This radiation is nearly uniform in all directions, suggesting that the universe is homogeneous and isotropic, the same everywhere and in all directions. If the universe is both homogeneous and isotropic, it might also be infinite. Another line of evidence comes from the geometry of space. According to Einstein's theory of general relativity, the curvature of space determines the overall shape and size of the universe. Observations suggest that space is flat, and in a flat universe, space could extend infinitely in all directions. However, it's important to note that the hypothesis of an infinite universe is just that, a hypothesis. It's a possibility based on our current understanding and observations, but it's not definitively proven. It's one of the many ideas that scientists are exploring as they seek to unravel the mysteries of the cosmos. An infinite universe, if true, could have profound implications. An infinite universe could reshape our understanding of the cosmos. This is a profound statement that, in many ways, sums up the vast implications of infinity. If the universe is indeed infinite, it could challenge or complement our existing cosmological models. Consider our current understanding of the universe. It's vast, it's expanding, and it's filled with countless galaxies, stars, and planets. This model, however, is based on what we can observe. It's bound by the speed of light and the limits of our technology. But what if the universe extends beyond our observable horizon? What if it goes on forever? An infinite universe presents a paradigm shift. It means that the cosmos isn't just vastly huge, it's limitlessly so. This could have significant implications for our understanding of the universe's origin, evolution, and fate. For instance, if the universe is infinite, does it mean it had no beginning? And if it has no beginning, can it have an end? These are profound questions that could challenge our existing cosmological theories. Moreover, an infinite universe could complement our models by providing a broader context for understanding cosmic phenomena. For instance, the idea of an infinite universe could help explain the uniformity of the cosmos. If the universe is infinite, then it's possible that every region, no matter how far apart, could have evolved from a common state. This could account for the remarkable uniformity we observe in the cosmic microwave background radiation. Moreover, an infinite universe could imply an infinite variety of structures and possibilities. Every conceivable arrangement of matter and energy could exist somewhere in the cosmos. This could mean an infinite number of galaxies, stars and planets, and perhaps even an infinite number of life forms. This idea not only enriches our understanding of the cosmos, but also expands our imagination of what's possible. In an infinite universe, the possibilities could be, well, infinite. This is a profound thought that underscores the vast implications of infinity. It challenges our understanding, stretches our imagination, and inspires us to explore the cosmos with an open mind. One theory that supports the idea of an infinite universe is cosmic inflation. Now, cosmic inflation isn't about the universe going on a shopping spree and blowing up its credit card. No, it's a scientific theory that tries to explain a lot about our universe, including its seemingly endless expanse. Here's a quick lowdown on cosmic inflation. It's a theory that posits that the universe, shortly after the Big Bang, underwent a rapid, exponential expansion. This isn't just a leisurely stroll across the cosmos. We're talking about an explosion of growth that's faster than the speed of light. This super swift expansion smoothed out the universe, making it isotropic and homogeneous. In simple terms, it's why we see a pretty uniform universe wherever we look. But how does cosmic inflation lead us to the idea of an infinite universe? Well, if the universe inflated at such an enormous rate, it could have become infinite. It's like blowing up a balloon, but with no limit to how big it can get. The balloon, in this case, is our universe, and cosmic inflation is the air pump. Cosmic inflation also gives us a universe that's flat on a large scale. Now, this doesn't mean you can take out your spirit level and start measuring. It's about the geometry of the universe. A flat universe, according to Einstein's theory of general relativity, can be infinite. So if we combine the idea of a flat universe with the theory of cosmic inflation, we get a universe that not only could be, but likely is, infinite. Do note, though, that these are theories. They're based on our best understanding of the universe, backed by mathematical models and observational evidence, but they're not set in stone, and scientists continue to refine and challenge these ideas as we learn more about our cosmos. So, an infinite universe isn't just a wild idea, there's some scientific grounding to it. But remember, the universe doesn't really care what we think. It just is. And that's the beauty of it. If our universe is infinite, then it opens up the possibility of other universes. This is where we step into the realm of the multiverse hypothesis. The multiverse theory suggests that our universe is not the only one, but one of a potentially infinite number of universes. This concept is not as far-fetched as it might initially sound. If space is infinite, then it's possible that the conditions we see in our universe, the laws of physics, the distribution of matter, the formation of galaxies, could occur elsewhere. And by elsewhere, we don't mean in another part of our universe, but in an entirely different universe altogether. These other universes, each with its own laws of physics, may exist in parallel to our own, separated by dimensions we cannot perceive. Some of these parallel universes might be very similar to ours, perhaps with minor variations. Others might be drastically different, with unique forms of matter, energy, and physical laws. But how do we connect the dots between an infinite universe and the multiverse hypothesis? Well, the key bridge between these two concepts is the theory of cosmic inflation. According to this theory, in the earliest moments after the Big Bang, the universe underwent a rapid expansion. This expansion could have created bubbles of space-time, each developing into a separate universe with its own unique properties. The multiverse hypothesis is still just that, a hypothesis. It's an idea that pushes the boundaries of our understanding, and it's not without its critics, but it opens up a universe, or rather, a multiverse of possibilities. It challenges our perception of reality and drives us to ask even bigger questions. In a multiverse, every possibility could exist somewhere. Every outcome has a place. It's a concept that is both awe-inspiring and humbling. Because an infinite universe could mean that we are just one of many universes out there. Let's summarize what we've learned about the concept of an infinite universe. We began by exploring the captivating idea that our universe might not have a boundary, a concept that has been pondered by philosophers, astronomers, and curious minds alike for centuries. We dived into our current understanding of the universe, the observable one, which is constrained by the speed of light, a cosmic law that makes us spectators of the past rather than the present, as the light from distant celestial bodies takes time to reach us. We then ventured into the hypothesis of an infinite universe, a concept that, despite being mind-boggling, is entertained by scientists due to the flat curvature of the universe and the idea that it could extend beyond our observable horizon. The implications of an infinite universe are profound. It not only challenges our cosmological models, but also opens up an infinite array of possibilities. Infinite galaxies, stars, planets, even the potential for an infinite variety of life forms. We also explored the concept of cosmic inflation, a theory suggesting a rapid expansion of the universe shortly after the Big Bang. This theory supports the idea of an infinite universe, as it proposes that the universe expanded exponentially, possibly leading to an infinite cosmos. We also touched on the multiverse theory, a hypothesis that our universe might be one of many, possibly infinite, universes, a concept that adds another layer of complexity to our understanding of the cosmos. And finally, we looked at how our understanding of the universe is limited by what we can observe. Areas beyond our observable universe remain a mystery, and whether we will ever be able to explore these regions remains an open question. The concept of an infinite universe is a fascinating one, suggesting that our understanding of the cosmos is still evolving. It's a reminder that there's still so much more to discover. So what if the universe is infinite? What an extraordinary journey we've embarked on today, exploring the concept of an infinite universe. It's a hypothesis that opens up a realm of endless possibilities and challenges our understanding of the cosmos. We've delved into our current understanding of the observable universe, a vast expanse that is already mind-boggling in its size and complexity. However, if the universe is indeed infinite, we're confronted with the idea of limitless galaxies, stars, and planets, a notion that is both thrilling and overwhelming. We've also touched upon the implications of an infinite universe. It could challenge existing cosmological models, yet at the same time, it complements theories like cosmic inflation and the multiverse hypothesis. Seeing our universe as infinite might even affect our understanding of phenomena like dark matter and quantum mechanics. And let's not forget the philosophical implications. An infinite universe might force us to reconsider our understanding of existence, purpose, and the nature of reality. It's a thought that's bound to stir up deep philosophical debates, and perhaps even influence our perception of our place in the cosmos. Despite these fascinating discussions, it's important to remember that the concept of an infinite universe is still a hypothesis. There's a lot we don't know, and our understanding is limited by what we can observe. However, the quest for knowledge continues. Scientists are tirelessly working to explore this hypothesis and unravel the mysteries of our universe. Whether we're talking about observable effects on Earth, the potential evolution of cosmic structures, or the possibilities of intergalactic travel, the idea of an infinite universe is a treasure trove of research questions. It piques public interest and stirs up curiosity, pushing us to keep exploring, keep questioning, and keep learning. Whether infinite or not, the universe is a vast, fascinating place. As we continue to explore and learn, who knows what other mysteries we'll uncover. So keep wondering, keep imagining, and remember, the universe is an enigma, waiting for us to unravel its secrets.